Okay, let's get started here. 5.4, the fundamental theorem of calculus. This is what it all comes down to. Almost everything you do for the rest of this semester will have something to do with the fundamental theorem of calculus. Okay? So let's talk about how we approximated, or how we would find areas of the shaded regions. So what did we do in this case? So how did we find the area from 1 to 3 so far in this course? What did we do? I heard somebody say it. That R word. Yeah, rectangles are part of it. Riemann Sums. So we could use Riemann Sums. Is it I before E after C or no? Yes? Okay. That rule doesn't apply all the time, which really annoys me. So we can use Riemann Sums to approximate. So we did that. Hopefully you remember a little bit about the Riemann Sums. We just made rectangles for the most part. Whether the rectangles, the height went to the left or went to the right or went to the middle. Or we did the more accurate but yet more annoying trapezoids as well. What about this guy right here? How would you find the area of this one? So what course would you say that we would use the most to figure out this one? This is just geometry. So you can find areas under the curve with Riemann Sums, but that's only to approximate. You can use geometry. They'll give you the exact answer, which is super nice. But like, could you use geometry on this first one right here? Unfortunately, you really can't. Okay. The only geometry you can do is the rectangles or trapezoids, which is to approximate. So there is a way to find out the exact area here, and it is the fundamental theorem of calculus. Okay. So it looks like this right here. This is like the worst way to write the fundamental theorem of calculus. It's like here and then there. It really is this. I'm just going to write it right here. So you take the integral. That's going to be the same thing as f of b minus f of a. Please do note that the first one is lowercase and the second one is uppercase. Please do take note of that. So we have lowercase f and then upper. It's just notation. It's just saying that it's a different function. Because when you integrate a function, you get a new function. Okay? And it kind of says it right here. The antiderivative of f, little f of x is big F of x. It's just notation. Okay? So the fundamental theorem is just that right there. So all we're going to do to find the area underneath the curve, you just find the antiderivative, and then you plug in the upper bound and subtract the lower bound, and then boom, area. So, like, for instance, like number 1 right here. Real quick, I'm going to do a quick little sketch of this guy. You don't have to do sketches every time, but I just want to so you can kind of see what is going on. So, this is x squared minus 3. So it looks something like this. Alright. And here's 1. What's the value at 1? -2, right? You just plug in a 1. You get -2. And then if I plug in a 2, I'm just a little bit over. Right? So I'm like finding like this area right here. And then like a little bit of that area. So how do we do this? Let's say last semester in December. Like if I knew this area, so let's say this area was like 3 and this area was 1, what would the answer be? -2. Why is it -2? Yeah, negative areas below and positive areas above. Okay, but we don't need to draw anything out on this because all we do is just our formula. So we're going to find the antiderivative. What's the antiderivative of x squared? This is why we did our warm-up, so this wouldn't take as long. X cubed over 3? Okay, I'm just going to write 1/3 x cubed. And what's the antiderivative of the minus 3 here? Okay, we do not need a plus c here for these. Reason is because I'm subtracting this function minus that function. So if I have a plus c here and a plus c there, what happens to the plus c's? They cancel. So do I really need the plus c here? No, I don't. And then this, I'm going to use this little bar right here. That just means evaluate from something to something. So we're going to evaluate from 1 to 2. I'm sure that notation is new to you. I mean, we kind of looked at it a little bit when we did derivatives, like we had to evaluate, but very, very little. So let's go ahead and plug in a 2. So I'm going to get 1/3 times 2 cubed minus 3 times 2. Okay, I'm going to find that value and subtract it by 1/3 times 1 cubed minus 3 times 1. I'm showing a lot of work. You will not need to show this much work. I just want you to see everything that's going on. Is that zoomed in enough? Am I writing too small? Or am I good? No response. Okay, I'm perfect. It's okay. Alright, I like the honesty. It's okay. What is 1/3 times 2 cubed? 8/3 minus plus. Why is it a plus? Distribute the negative. Okay, what am I going to get here? What's let's do 8/3 minus 1/3. What do you get? 7/3 minus 3. Okay, if it's a free response, you're actually good right there. But this problem would be more of a multiple choice. So let's simplify even further. This would be 7/3 over 9/3, which is which makes sense that this answer is negative, because if you look at my picture right here, I mean, it's not a perfect picture, but we have more negative area than we do have positive area. So it makes sense that the area between 1 and 2 is going to be negative. Yeah. Because I distribute this minus sign to there. Good catch for you. Alright, any question on this one? You want to try 2 on your own? Yeah. But no matter what you said, I was going to have you do it on your own anyway. So try 2 on your own here. See how you do. So find the antiderivative, plug in those endpoints. Please use correct notation. Don't be lazy. Bless you. Did I get the antiderivative right? I skipped a lot of steps. I don't know if it's right. I think it's right. Anybody can confirm if this is right or not? I'm good. Alright, I hear lots of like, what happened? So let's go through it real quick. If it's 3x to the 1/2, well, let's add 1 to that 1/2. What do you get? X to the 3/2. So you have to divide by. Alright, so it's like 2/3, and then what's in front of that? A 3. So those 3's cancel out. Alright, we're good now?
Okay, so how does it try to shoot from 3? I don't really get where you got that from.
Because you divide by the exponent. So dividing is the same. Dividing fractions is as easy as pi. You just flip the second and multiply. That's why I flip it. Alright, so now I evaluate now. I'm going to get 2, 4 to the 3/2, which some people forget how to do that, so I will remind you while I shake my head in disgust. What is 4 to the 3/2? Somebody walk me through how to do it. Don't just tell me the answer. So take the bottom, so square root 4, which is 2, and then you're going to do the top, which is a cube, so it's 2 cubed. 8. So what's 2 times 8? 16 minus. Answer is? How do we do on that one? Alright, like 4 people like giving you a thumbs up and everyone else is just like, ugh. Alright, let's go ahead and do 3. Let's do it together because I don't want you like staring at this going, what do we do? Alright, so let's go ahead and do the integral from 0 to pi over 4 of secant squared here, dx. And if you don't know what it is, look at your formula thing. All we know, the only antiderivatives we know to do are either to draw them or to use a formula. That's all we know right now. There's nothing else that we can do, which is really nice, trust me, because when we start doing other tactics to do this, you've got a lot of options, and that's when it gets rough. But right now, it's either a formula or you can draw it. Can you draw secant squared accurately and get everything down? The answer is no, you can't. What's the formula? What's the antiderivative of secant squared? Somebody said it? Tangent. You need to know that. I think we learned all the trig formulas and then the reverse power rule. I think that's really the only formulas we know at the moment. So plug this in. We're going to get tangent of pi over 4, which I really hope you know what that is, minus tangent of 0. What is tangent of pi over 4? 1. Great. Minus, which is? Nice clean answer. Alright, let's go ahead and look at 4 here. We integrate from 0 to 2 of absolute value of 2x minus 1. Is there a formula for absolute value? So what's the other strategy we know since there's not a formula? Draw it and use geometry. How the heck do I draw this? I'm going from 0 to 2. Alright, so I'll kind of do this. Someone just said plug it in to draw it. Is that really what I do? Just plug it in. Okay, so we need to know how to graph absolute values. So where's the, how do I find the vertex of the absolute value? It's -1. Huh? I have to say yes? What if I don't agree? Oh, you're saying plug in a 0, it's at -1. But it's not at -1. Isn't it +1? I'm going to find an issue with what you're doing right now. I'm just going to go along with all of you, and I can't wait to find the issue. So if you're watching this on YouTube, I don't trust these people. I don't trust these people. Okay, and then what do? So I'm up here at 1. And then what am I at 2? At 2, I'm at 3. So I'm here and here. What do I do now? Draw the straight line. If you are watching YouTube, do not do this. So that's the graph of absolute value of 2x minus 1. Wait. What do you mean the other way? When did you graph absolute values in your career? I don't think you have. Because I teach pre-AP, pre-calculus. We're yet to actually graph absolute values, which is really upsetting to me. Okay, somebody just said something, like, correct. What about the 1/2? Okay, so what letter of the alphabet does an absolute value look like? This does not look like a V. Okay. Okay. The vertex is at 1/2. How do you know that? Yeah, find the x-intercepts. So set it equal to 0, and then you're going to get this right here, which is 1/2. Okay? It's a V. And now, what's the slope of this V? It's 2. Okay? She should be going up 2 over 1. Now, this was just a little weird because we're starting at 1/2, and I need to end at a 2. So you can either go like up 2 over 1, or you can just plug in the endpoints, which we already did. So what are the endpoints? 1 and 3. Okay. I'm going to shade it. We need to find the area of each of those. Okay, I'm not upset at you for not knowing how to do it. I'm upset at the system. The system you were brought up in. Which hopefully no one watches this video, because I'm making fun of, like, not you, but whoever made up the curriculum for pre-calculus. Which I currently teach, so, like, how much making fun of it can I do? Alright, so what's the area of this first blue guy? So what, the height's 1, and then the base is 1/2, so you said it's 1/4. Plus, this base right here is 3/2, and this height is 3. So what's the area of the second triangle? 9/4? I like 9/4. Why do I like 9/4 better? So these match up a little bit nicer. So what do I get as an answer? 10/4, which is also 5/2, which some people are like telling me it's 2.5, which I agree. I'm still shocked that we don't know how to do absolute value. Did you graph it in the second semester? I haven't taught the second semester yet. Actually, I'm trying to think of my old school if we did this in pre-calculus. I don't think in my old school we did in pre-calculus either, but we did it very heavily in algebra 2. Okay, now that I'm disgusted with the system, let's move on. Number 5 here. This is just a different way to ask the problems that we've been doing. It's just a different way to ask it. It says find the area of the region bounded by the graph, which is right there, y equals 2x squared minus 3x plus 2, the x-axis in the vertical lines, x equals 0 and 2. I just want to walk you through how to write down the integral. So here's the setup. What's the lower bound? And I'm talking about x's. 0. What's the upper bound? What's the function? And now it's a problem that we've been just doing, right? Do I need to go through this problem, finish it? I don't think so, right? Because this one's pretty quick. Just, yeah, plug in stuff. Well, no, don't plug in 0 until you find the antiderivative and then plug in. That's what you meant, though, right? Oh. Okay. You just find the antiderivative, and then you just plug in 2 and you plug in 0. Do I just need to go through it since I'm already talking about it? Okay. The antiderivative is going to be 2/3 x to the third minus 3/2 x squared plus 2x. That's really annoying to plug in. And then you just go from there. Actually, this is a good time right now because of like sheer laziness. I don't like those numbers. To show you how to do this on a calculator. It's not that hard. You just gotta find the button and then you're good. And there's a glare. There we go. Okay. So if you go to alpha F2, there's something that says int, FN int. What do you think int stands for? Integer? No, integral. And then boom, you literally just type in what we just did. So we go from 0 to 2 of 2x squared minus 3x plus 2. And there you go. 3.33333, which is 10/3. There will be times where you do need to use a calculator because the function will be too difficult. Like, even to this day, there are stuff that you cannot take the integral of by hand. You can't. So, prove it. I just said you can't do it. So what I'm going to do is write down the question and say I can't do it.
Like, show us an example. Show your work.
I think that's one you can't do. I don't think you can do that one. Plug in numbers? Sure, we wanted to plug in. 0 to 1? 0 to 12? That's not going to work. I can guarantee you the calculator is going to like take that and like spit it out and say, nope, too big. It will. E to the x squared. I mean, the calculator can do it, but you can't do it by hand. And I'm going to say that the calculator probably can't do it because I bet you it's too big. That's how hard it's thinking. Yeah, it's 1.444 times 10 to the 61st power. It actually does something called it rewrites this as a Taylor series, like within the calculator. With the Taylor series, it makes every single possible function out there into a polynomial because you can integrate any polynomial, which is a fun thing to move forward to say that you're not going to do Taylor series, but BC does, which is totally fun. I love me some Taylor series. I'm disappointed I can't teach it this year. You know what? After the AP, I'll just teach it to you. All of you will just be sleeping, or most of you will show up so late that it won't even matter. I'll just teach it. Hey, let's go ahead and, set up 6. Just set it up real quick and then see if it matches with me. It should only take you 30 seconds. Read 6, just set it up. I won't practice finding the antiderivative of that because, again, we have independent practice later where you can try it out. All right, what do we get? Integral from 0 to pi of, make sure you have a dx there. And then from there, you just take the antiderivative of both of those. So we just get 1/2 x squared minus cosine x divided from 0 to pi, which is like super annoying because your answer is just going to be ugly because you're going to plug in a pi here. So you're going to get 1/2 pi squared minus, what's cosine of pi? -1. So it's +1. And then plug in, so minus, plug in a 0, you're going to get 0. Plug in a 0, what's cosine of 0? It's 1. But we're subtracting it, right? So it's -1. Wait, but we're subtracting the subtraction, so it's actually really a +1. Right? I'm just kind of skipping steps here, which is not so good. But I'm going to do it anyway. That's what I do. And while you're doing that, I typed in, there are integral calculators out there on the internet. So I typed in what the antiderivative of e to the x squared is. YouTube will not be able to see this, but here's the antiderivative of e to the x squared. Square root of pi phi of x all over 2 plus c. It totally could have did that. Yeah. So, phi. Yeah, it is dark math. Phi. Not supposed to. It's complex analysis stuff. Okay, hey, let's talk about if it's a piecewise function right here. So we have a piecewise function of 6 when it is greater than 1, and then we are 3x squared when it is less than 1. We need to integrate from -2 to 3. So essentially, we need to break this up into 2 different integrals. Okay? So where's my breaking point? 1. So this is going to equal integrate from -2 to 1 of h of x plus integrate from 1 to 3 of h of x. What function are we using for h of x between -2 to 1? 3x squared? And what function are we using between 1 to 3? Just 6. These actually come out pretty nicely. Antiderivative of 3x squared is? It's up there. Do that in a second. Plus antiderivative of 6 is 6x. What do we get here? So you're going to get a 1 minus negative 8. Right? Is that correct? Yeah. Okay. And then plus 18 minus 6. So 9 plus 18 minus 6. 21. Blackjack. Are we cool so far? I hope so. Okay, now we kind of go into like word problem stuff, which is a little bit of, or really review, I would say. A little bit of review from what we did in December, a little bit of review for when we did like the position and the velocity and the acceleration and stuff like that. Okay. So here's two things to know. So, and we talked about this, I think, a little bit in December, that change in position is this guy right here. So if you integrate velocity, you get displacement. If you integrate the absolute value of velocity, you get the distance traveled. And for this, I'm just going to use all calculator, because typically these problems are all calculator. So through number 8, part A and B. So this looks like this came from a free response. At least two of these parts did. So the velocity in feet per second of a particle moving along a line is, it says it right there, where t is in time seconds. How would you find the change in position of the particle on the time interval from 1 to 5? Now we're given velocity. Makes it a little different, right? If I was giving you position, we could have did this first semester. If I would have gave you position, all you do is you just plug in the endpoints and you're good. But I gave you velocity. So you actually need to integrate from 1 to 5 of v of t. That's going to give us the change in position. Which I'm going to use my handy dandy calculator. That's not the right thing. It's 4. So integrate from 1 to 5 of this function, which is this guy right here. Sorry, I didn't know it was in the glare. Oh, I hate this glare. Just integrate it, you're going to get 10.667 units is feet. Okay, so that's just where they started at 1 and where they ended at 5. This is the difference between the two positions. But how much distance does it actually travel? Do the same thing. You're going to integrate from 1 to 5. Do you know how to do absolute value in your calculator? It's been a while. I think everything's in this alpha 2 button. Alpha 2, F2. Oh, look at that first one. Absolute value. And you just type in the exact same thing. And kablamo. A little bit bigger. So integrate from 1 to 5 of the absolute value of v of t dt, and we're going to get 11.833 feet. Alright, any questions on that? That's just pretty straightforward. It's just formulas. Yeah, what's up?
For absolute value, would most of those problems be like thinking your calculator?
Yeah. These are mostly calculator. Usually on AP, because you have two calc, 4 non-calc. Typically, the 2 that are calculator use integration, and then the 4 that don't usually are first semester stuff. They'll throw in some, like one of the parts will be integration, but it won't be difficult integration. But for the most part, problems like these are going to be calculator. I feel like I just did this problem. I don't know when. Because I do calculus all the time, so I must have just did it recently. Okay, so number 9, a metal wire, length of 8 centimeters, is heated at one end. I remember where I did this problem. The table above gives the selected values of temperature in degrees Celsius of the wire from the heated end. The function t is decreasing and twice differentiable. This is actually a big time review problem. Big time. Estimate t prime of 7. How would we do that? I heard someone say it. What? You're just finding average rate of change. So find the secant. Let's go ahead and find the secant here. So we're going to get t prime of 7 is going to equal t of 8 minus t of 6 all over 8 minus 6. I believe like this question was on your quiz that you took. Pretty close to it. So what is t of 8? It has everything. 55 minus 62 all over, which is negative 7/2. Indicate units of measure. These notes are terrible. Okay, sorry. What is it? Someone just said degrees Celsius. That's half right. It's a derivative. It's a rate of change. So it's degrees Celsius per... Which is like super weird, right? I'm going to explain what's going on here. So here is some wire. Definitely not to scale. This is my pen right here. Okay. So I took something, I heated my pen right here, okay? So it's very hot right here, not as hot down here. You agree? So it's very hot here. So at here, it's 100 degrees Celsius, and over here, it's only 55. So what's going on at 7, which is about right here? What's the change? Well, the change in the temperature is it is decreasing at about 3.5 degrees. Okay, so the change in temperature is decreasing a little bit there. So that's what's going on there. Okay, let's find t prime, the integral of 0 to 8 of t prime of x, and indicate units of measure. How the heck do I do that? If you're thinking fundamental theorem of calculus, you are correct. Okay. Because what is the fundamental theorem of calculus say? Isn't that equal to t of 8 minus t of 0? Because isn't the antiderivative of t prime just t? So it's 55 minus 100, which is equal to negative 45 If you integrate a rate of change, it becomes just whatever the initial value is, so like position function. Bless you. All right, let's explain. What the heck did we just do? There's what part C is saying. Using correct units, explain the meaning of it. What does that mean? We're not doing calculus right now. We're just using our brain. What does that mean? What happened from 0 to 8? Okay, so it's what? What decreased? Okay, so the temperature of the wire Increased or decreased? Decreased. (45°C). You have to mention the endpoints. Did I mention the endpoints yet? So how do I mention them? From 0 to 8 centimeters. So these problems are kind of weird. These are just like 1-point problems where they say interpret it. You have to state the endpoints. People forget that. You have to state what that is actually equal to. So we did those two things. So we state what it was equal to. We say the endpoints, and then it's really just we integrated a rate. So it's just the temperature. Because before we had the temperature per centimeter, we integrate that. We get rid of the per centimeter. It's just the temperature. We'll have more practice on that with a lot more of our free responses. All right, not too much left going on here. Super important problem right here. Love this problem. Lots of problems in calculus. Use this problem, which is I'm upset that there's not more problems like this on the notes because this is super duper important. Okay, so the population of insects increases at a rate of L of t equals whatever that function is. Insects, is that an L or an I, you think? I'm going to go with an I. I'm going to change it from lowercase l to uppercase I. Insects per day. Find the insect population after 6 days if the initial population was 35 insects. Okay, I'm just going to walk you through it. So essentially, this is a rate. If I want to get down to the population, I have to integrate. Okay? So I'm going to integrate from the information I have. I need the information that I have and the information that I need in this statement. So what's the information that I have? 6 days is what I need. It wants you to find it at 6 days. But what do I have? The initial. What's the initial days? Days. 0. I'm integrating from 0 until 6 of this uppercase I of t dt. Okay? Which, using the fundamental theorem of calculus, gives me, isn't it just I of 6 minus I of 0? Okay. Well, what is this value right here? Calculator. Can't I just integrate that right there from 0 to 6? So, integrate, see how helpful the calculator is. 0 to 6 of this 200 plus 10t plus 0.25t squared. I'm sorry today's notes are kind of long, but it is what it is. We're just about done here. Okay, so this is 1398 equals, do I know I of 6? I don't. I want that. Minus, do I know I of 0? 35. How do I find I of 6? Just add 35. So I of 6 is equal to, if you don't know, just hit plus 35 because you have a calculator in front of you. 1433. There you go. Use the fundamental theorem of calculus whenever you get a chance. They could also ask you questions of, hey, if the insect population was, after 6 days, 1433, what was the initial population? They can ask that. So all you do is everything is reversed. Okay? So always write it out this way. This is super important. I would know that. You use this all the time in these word problems. Okay? And this 11 is just review for stuff we just did. So I'm not too worried about it. So I'm just going to kind of skip on over it. You cool with that? Yeah, after 45 minutes of notes, I would want to skip over it too, which is why I skipped over it.